All right, this is for Chemistry CP, a debriefing on how to read chemical reactions. Write a sentence description for each of the following balanced reactions. Number one, for aluminum or aluminium, atoms will work, solid, combine with, three, oxygen, or if you like, three, gaseous, oxygen molecules, because these are considered molecules, not atoms, to create two solid aluminum oxide molecules. Ta-da, that's it. Number two, four solid sodium atoms combine with one aqueous CrO4 is chromate. Sn is tin. Here, chromate has a 2 minus charge. And here we need two of them. So this would be aqueous tin, Roman numeral 4, chromate. To produce two, oh, and I guess I could have said aqueous here. Oh, I already said it. One aqueous tin 4 chromate molecule, molecule, to produce. Good thing you don't have to read my handwriting, huh? I have to read yours though. To produce two sodium chromate molecules aqueous and one tin atom solid. So when tin is by itself, it doesn't have any Roman numerals. It's always neutral. It's not a cation. Number three, three aqueous magnesium sulfate molecules combined with two. So this is cyanide. Cyanide is always a 1 minus charge. I need three of them for this iron. So this is going to be iron Roman numeral 3 cyanide. I'm going to call them a molecule. Molecules. I don't know if they're ionic compounds. To produce or to make, just for a little variety, to make 3, and I guess I could say with 2 solid iron 3 cyanide molecules to make 3 aqueous magnesium cyanide molecules and 1 iron sulfate is always 2. So this is still Roman numeral 3. Iron Roman numeral 3 sulfate solid molecule. Answer the following for the given balanced reaction. It says 4 aluminum bromide solids plus 1 lead 4 sulfate solid yield 2 aluminum sulfate solids and 3 lead 4 bromide solids. If the reaction begins with 20 molecules of aluminum bromide, how many molecules of each product are made in the reaction? So this is where the ratio of the coefficients are the only thing you care about. So for every 4 of these, I need 1 of those to make 2 of these and 3 of those. So if I bump this from 4 to 20, I'm multiplying it by 5. So I can multiply everything else by 5. In that case, 2 times 5, I need 10 molecules of Al2SO4 3, and 3 times 5 is 15. So, and 15 molecules of PbBr4, lead 4 bromide. That's all for number 4. Number 5, if the reaction uses 300 molecules of lead 4 sulfate, then how many molecules of each reactant and product are needed or made in the reaction? So the only thing we care about is the ratio of what we have originally to what we have now. So originally we have 1. For every 4 of these, we need 1 of those to make 2 of these and 3 of those. Now, instead of just 1, I actually have 300 of these. So everything gets multiplied by 300. 4 times 300 is 1,200 of the aluminum bromides. 300 times 4. 300 times 2, or 2 times 300, is 600 molecules of aluminum sulfate, and 300 times 3 is 900 molecules of lead 4 bromide. You should say the word molecules. Molecules, molecules, molecules. Number 6, if the reaction creates 8,000 molecules of aluminum sulfate, then how many molecules of each reactant are needed in this reaction? Well, so looking at the originally balanced chemical reaction, the aluminum sulfate is on a ratio of 2 compared to everyone else, 4 to 1 to 2 to 3. So to go from 2 to 8,000, I have to multiply it by 4,000. 2 times 4,000 is 8,000. So I have to multiply each reactant also by 4,000. 4 times 4,000 is 16,000 molecules of the aluminum bromide and 1 times 4,000 is 4,000 molecules of the lead 4 sulfate. Last question, number 7. If the reaction makes 9.0 times 10 to the 12th molecules of lead 4 bromide, then how many molecules of aluminum sulfate are also created in the same reaction? Well, these are the two products. The ratios are 4 to 1, make 2 and 3. If I am making 9 times 10 to the 12th power of the lead 4 bromides instead of just 3, then that's a multiplication factor of 3 times 10 to the 12th power. So I multiply the other product also by 3 times 10 to the 12th power. 2 times 3 is 6.0 times 10 to the 12th power, and that's how many molecules of aluminum sulfate I end up making. Ta-da! This ends the debrief on how to read chemical reactions.